Good morning, ladies and gentlemen. Welcome to Katsina State Senior Secondary School's online connect, powered by Exponential Computers. Physics lesson for SS1 students, week 6 and 7. Also, the presenter I, Ismail Bara. So, for the week 6 and 7 contents are here, which is the concept of field, types of field, gravitational field, electric field, and magnetic field. And lastly, we are to talk about or to explain the properties of a force field. So, the first content, that is the concept of field. So, when we say field, a field is a concept introduced to describe a region under the influence of some physical agency, such as gravitation, electricity, magnetism, heat, etc. So let's come back to the definition and see. So when we say field is what it was introduced, and when we say something is introduced, like it was created to describe a region under the influence of some physical agency. And when we say physical agency, we mean the physical quantities, and those quantities are the gravitation, electricity, magnetism, heat. So this one are the physical quantities or physical agency. So field is a concept introduced to describe a region. And when we say region, we're talking about like a space under the influence of some physical quantities or physical agencies, and those quantities are the gravitation, the electricity, magnetism, heat, etc. So on, there are many. So I feel it was introduced to describe those quantities. So, and there are some quantities here or some fields that we are to talk about, like the gravitational field, the electric field, and the magnetic field. So a field is a concept introduced to describe a region under the influence of some physical agency, and these are the agencies. So let's go to those quantities or those agencies and see what they are trying to tell us. So here we are at the ties of those fields, and that those ties of those fields, all of those quantities, they are under these two types, and those two types are the vector field, scalar field. So we have only these two types of field. So those quantities that we have talked about, the gravitation, the electricity, or the heat, or the magnetism, or any one of them. So they has to be under this one. So and that is the types of field that they can be under the vector field or they can be under the scalar field. So normally we have these two types of field. These are the two types of field, vector field and scalar field. So these are the two types. So when we say a vector field is that field which is usually represented by line of force. And when we say line of force, like maybe a mark or a line of those force, the line of the force, a normal line that you know, a line of that force. So normally it is a representation by line of force. Example of let me show you the line of force, like this one. If you see these terminals, the red one and the black, the green one, that is this one are the line field, like the line of force. So this is the line that we are talking about. So and it is normally usually represented by line of force. So a vector field is that field which is usually represented by line of force. And the example of those vector fields are the like the gravitational field. So you see a gravitational field is under types of field under vector field, and also a magnetic field is under a type of field also under vector field, and also the electric field. So also if you look at this one they are under the types of field of vector field. So this is about vector field. While a scalar field is that field that is not represented by line of force. So you see a scalar field, they don't have those lines. They don't have line of force. So you see A scalar field is that field that is not represented by a line of force. And the example of scalar fields include a region which distribute of temperature. You see, they don't have a line of force. A temperature don't have a line of force. Or a density. You see, a density also, it doesn't have a line of force. So you see, this is about the types of field, the scalar field and the vector field, and the example of them. So you see, these are the types of field. So here we are going to talk about the number 2 concept of week 6 and 7 class or physics lesson for this week. So and we are at the gravitational field. So normally a gravitational field is a force field that exists in the space around every mass or group of masses. And when we say group of masses, that means that the masses are not one, there are many. So it is a group of masses. It's said to exist near anybody that possesses mass. So when we say gravitational field, so we are talking about that force field, that like let's say a force that is normally used to absorb an object. Like let me give you an example. Like maybe if you take a ball in your hand and you throw it off in the sky, so you see that ball or a stone or something like that. So if you throw it off in the sky, so within short period of time, even it go up, it reach some certain level. So that ball or that stone or that object will start to come down, will start to come down. So that coming down, it is due to the gravitational field. It is that force that or that power, let's say power that is bringing that object down. So you see, and that coming down of that object, it is due to the gravitational field. That is why it is a gravitational field. It is from the gravity. It is the gravity that absorbs that particle or that object to come down. So it is due to the gravitational field. So normally a gravitational field is a force field that exists in the space. So we see, and when we say in the space we are talking about maybe let's say in the sky. So you see, not in the ground, on the ground or underground. So on space around every mass. So all group of masses. So you see each mass. And when we are talking about maybe let's say mass, we are talking about quantities. If you are talking about mass, like a quantity of an object, how heavy it is, so the mass of it. So the group of masses, it's said to exist near every mass, every body or every particle or every object that possesses mass. So you see, a gravitational field already exists if that body has or that object has a mass. And when we say mass, like a quantity, if that particle or that object or that body has a mass, so a gravitational field already exists there. So you see, this is about the gravitational field. And normally a gravitational field has this formula. And this formula normally it was introduced by one of the best scientists, that is Sir Isaac Newton. He's the one that discovered gravitational field. He's the one that discovered gravitational field. So you see, that is the formula. That is the Fg is equal to capital G m1 m2 all over r square. So normally this G is a constant of proportionality. It is the universal gravitational constant, this G. And this M, the M1, the M2, that is the masses that we are talking about. The mass, that is the M1, and the M2, that is the masses that we are talking about. Also the R. Then the R is the distance between the center of those masses. That is the distance between mass 1 and the mass 2. The distance, how the distance covered. The distance, that is the R, and the R is in square because it is two masses. That is why they are in square. So this is the formula for calculating gravitational field. If you are to calculate gravitational field, and like this G is the gravitational constant. It has a constant value. And when we say something constant, that will mean that it is not changing. That constant value is not changing, which is 6.674 times 10 to the power of minus 11 meter cube per kilogram per second square. So this value is a gravitational constant value. It is not changing. This value is not changing, it's constant, only meant for this capital G. The R can be given, and the M1, the M1 can be given, the M2 also can be given, also the R, the distance, it can also be given, but the mass, the no sorry, the G is constant, is not changing. So this formula is used for calculating gravitational field, and this is the meaning or the explanation of the gravitational field. That set is the force exists in the space around every mass or group of masses. So this is about the gravitational field. So we are the electric field. Also electric field is also types of field. So electric field can be defined as a region of space around an electrically charged particle. So you see, when we are talking about electric field, we are talking about the like from the electricity, from the charges. And when we are talking about the charges, we are talking about the positive charge and also the negative charge, and this one, that they are the one that bring or that form the electrically or the electric field. So you see, it is a region, it is a region of around electrically charged. And when we say electrically charged, we are talking about those positive terminal or those positive charges, or an object in which the charge body experience pulse. So you see, anybody or object that experience pulse, it experience, like maybe a flower has entered it or something like that. That body has a electric field, but that electric field is due to electrically charged particle, that is the positive charge and the negative charge particle. So electric field normally is come from the electrically charged particle, and those charged particles, just like this diagram here that you are seeing, the red color that you are seeing with the plus sign, that is a positive charge, and also the like the minus sign in blue, that is the like the negative charge particle. So you see, these two charges particle are the ones that bring or form electric field. So electric field can be defined as a region of space around an electrically charged particle, and these are the electrically charged particle, or an object in which the charge body experience force. So this is an electric field, and this is the formula for calculating electric field. So electric field is equal to F divided by Q, and this F is stand for the electric force. That is the force that experience that charges on that body, and the normally force is used to measure in Newton. That is the SI unit of the force. Force is used to measure in Newton, and also the charge divided by the charges. That is the charges. This two terminal. That is these two charges. That is the positive charge and the negative charge. This one are the one that form the electric charge. That is the force divided by charge in coulomb. That is the electric field. So normally electric field is equal to force divided by charge in coulomb. That is the unit of the coulomb and also unit of the force. The force is in Newton, and the charge normally is used to measure in coulomb. And this normally the whole general electric field is used to measure in in Newton per coulomb. And if you see here, you will see N per C, that is the Newton per coulomb, or voltage per meter. So you see, this one these are the SI unit of electric field, and also this is the formula for calculating electric field. So the last one among them is the magnetic field. So the magnetic field normally is also the region around a magnetic dipole or moving charge generate a field. So you see, when we say magnetic field, and when we are talking about this magnetic dipole, like maybe like let's say like the cardinal point, the one that we have normally on on our map, like the north pole, the south pole, like the west pole and the east pole. So normally a magnet, it only has a north and the south pole. That is magnetic dipole, the north pole and the south pole. So they are the moving charges, and they, as they are moving, they generate a field. So whenever they keep moving, they will generate a field. So that generation of that field that they generate, that is how they come and bring the magnetic field. Nobody. So a magnetic field is the region around a magnetic dipole or moving charge generate a field. So this one are the one that generated field. This field is known as the magnetic field. So you see, due to that moving, as they are moving around that magnetic dipole, that is let's say the head and the back, or the north and the south. These ones are the dipole, that is the magnetic dipole. So when they are moving, they will generate a field. So that field is called a magnetic field, and they normally is used to measure in Tesla. That is the SI unit of the magnetic field. So if you look at this diagram here, the one that have a magnetic line of force. So also if you look at it, we have a north N, that is the north pole, and also the S, that is the south pole. So you also see the line of forces. You see them, the one in black, that is the line of force here. So on this diagram on the right hand side, if you look at it, also this one is talking about a law, that is a law of electrostatic, and it says that if it says the like this, not this S, this no, firstly let's talk about the one that they repel. So a positive and the positive terminal used to repel it, and when we say repel, we are talking about they will refuse each other, and like a positive and the positive, they will refuse each other. Also the negative and negative will refuse each other. So you see, this is the law, and the one that attract each other, that is positive and negative. The positive and negative, that is that there is an attraction between them, because like maybe let's say you have a wire, like the positive and the negative. So you see, the positive and the positive, there's no attraction between them, but positive and the negative, that is attraction between them, they will react each other, there is attraction between them. But also a negative and the negative, they will repel each other, they will refuse each other. So this one here, we are talking about the one they attract each other, like they will attract each other. The one we have to like to this, we are like having two magnet here. So the magnet of the south and the magnet of the north, they will attract each other, they will come together and join. That is what we mean by this attract. They will join together, they will join each other, they will keep they will be in contact with each other, they will remain together. But when we are having this S and the S, that is the south pole and the south pole, if we, even if you are trying to put them together, they will refuse each other, each of them, they will not be in contact with each other, they will repel. And that is they will repel, they will not, there's no attraction between them. Why? Because they are in the same, maybe like say side, they are in the same side, that is the north, that is the south pole and the south pole, there is no attraction. A north pole and the north pole, there is no attraction. But a north pole and the south pole, there is attraction. That is the law of electrostatics. So you see, a magnet normally is used to follow this law. When you are having the mixture, they will react each other, they will attract. But when you are having the same, they will repel each other. So this is about magnetic field and the law of the law of electrostatic field. So this is about the magnetic field. So here we are to talk about properties of force field. And when we say force field, we are talking about those forces, those fields, those fields that we have finished talking about. And this force field, it comes from the types of force. So normally force, we have a contact force and a field force. So when we say field force, normally we are talking about that force that will not be in contact with, there's no interaction of contact of that object, the object will not be in contact with the particle, and that force will take the action, because there is no interaction between the force and the contact. But a contact force, that is the force and the particle, they will be in contact. And when we say in contact, maybe like we are trying to say like you have a spoon here, so you use your hand. Like if you use your hand and take that spoon, so you see that object and your hand, they are in contact. You use your hand and touch it and let's say pick it. But a pulse pill, and a force is like a force. The force will not be attracted with that object. Like if you take a magnet and you take let's say also the spoon or a nail. If you try to put that nail, you will see that nail will attract that magnet. So you see there is no attraction, but that nail attract that magnet. So you see, this is about force of attraction. So normally in simple term, a force field in physics is the area that is affected by another force. So you see, by that another force that you do is affected by that force. So this is about the properties of force field. So the number one properties of force field is talking about the gravitational field. So the number one properties of force field is that it sets any force acting on a body falling toward the center of the earth is given by F is equal to mg, that is mass times the acceleration due to gravity. So you see, any object that you throw on the sky, it will absorb that acceleration due to gravity, or that the gravity or that the gravitational field will absorb that particle to come down. This is what this one is talking about. So if this one is talking about, then that means that it's talking about the gravitational field, because it is the gravitational field that is talking about a force that will attract object to come down. So this is number one properties of force field. The number two that we have is a magnet has the ability to attract magnetic material. So you see, this one is talking about the properties of magnetic field. So you see, the magnet has the ability to attract or to take to take the magnetic material. And normally the magnetic material, like the iron or a steel or let's say aluminium or something like that, or metal. So these are the magnetic material. Normally a magnet used to attract it. So this is the property that is talking about the magnetic field. So the last one is also a property of force field, but this one is talking about the magnetic field. So it says that electric line of force never cross each other. So normally the electric line of force, that is those two charges, that is the positive charge and the negative charge, they will never they will never cross each other. So you see, and they, like maybe if you have a wire, the red one and the blue one, you are trying to put them together. So you'll see, if you put them together, you will see that maybe like there's a shock or a spark. So you see, they will never attract each other. So you see, this one is talking about the electric field. So this is the properties of force field. So I think this is the end of the week 6 and 7 physics class to the SS1 students. So I wish you best of luck.